Hello and welcome to the Z-Hut. Today I'd like to show you how to build a temperature control box for like a greenhouse, or you could use it for egg incubator or humidor, or lots of different uses. What this does is it has two relays, and the first one is activated if the temperature gets too low, and the second one is activated if the temperature gets too warm. And this also has a humidity sensor, so a third relay could be added to control humidity, or if you only needed the low temp, you could use this one to control humidity, or there's a couple different ways to set it up. I have it set up right now just as temperature because I don't need the humidity. I'm going to be using this for an egg incubator, but adding that humidity is real easy, and just check out the website. I'll have more information on there, and you'll find a link to the website in the description below. So of course we've got the two relays here, hookups for the relays, and if you're using this with high voltage, I'm actually using this to control some bigger 12 volt relays, so I didn't worry about putting a cover, but you're going to want to have some kind of cover on here if you're running 110 through this so you don't get electrocuted, and that's real easy. Just put something on there. That's up to you to come up with how to put that on, and these could also be mounted on the back side, but I just, for ease of access, put them on the front. So what we'll do here is I'll demonstrate it working, and we'll open it up and I'll show you the insides and how to build this, and then what we'll do is we'll go over to the computer after that and I'll show you the code for the Arduino board, which is what is running this. So we've got two potentiometers here. You can see the low temperature and the high temperature. That's what they control, and then it has the actual temperature it is now, and this is in Celsius. So right now in here it's 12 degrees. So if I turned this so it's above 12 degrees, the relay comes on. And I can show you that the relay is working. See, it's working. I turn it down, it shuts off, and then it activates this one. Now I'm only going to be using this side, but you could have something else hooked up for this side if you wanted to control something else, turn something on when the fan or whatever, the heater's not running. Now I also have this set up so that when it reaches that low temperature, you actually have to go several degrees warmer before it turns off. Now I have it set just for the demonstration at 5 degrees. When I hook this up to the egg incubator I'm building, I'll probably set it for like 1 degree, maybe 2. You can see there, yeah, she shut off. And then this side works the same. This side here, if the temperature gets too hot, it activates the relay. So I got it set at 8 degrees, and the temperature is actually 12, so it turns that on, and it has to, this side, once again, has to get 5 degrees warmer before it turns that off. All right, well, I'm going to, also I have, so you can turn the backlight off if you don't want the backlight always on. It doesn't turn the display off. I don't know if you can see on the camera. It still has the readings, but it just turns the backlight off if you don't want that on for some reason. This is optional. You don't have to add it. But I figured because this is always going to be plugged in, the LCD would probably last longer if the backlight wasn't always on. And also it uses less power that way too. Alright, so let's take a look at it. So of course we've got our terminal blocks for hooking the relays up. And I put two LEDs in here to show that when the relay's on, they turn on. Them are optional too. You don't need them. Them are just there to let you know. So if you're testing and something ain't coming on, you can look to see, is the relay actually turning on or not. Then we've got our push button. LCD screen, this is 16 character by 2 line. These are only like $3-4. They're real cheap. Then I got two potentiometers, one for the high and one for the low. And as you can see on the side here, that's the DHT11. That's a temperature and humidity sensor. Then on the other side, I have the plug-in to plug my wall wire into it to power it. You can power this anywhere from about 7 volts to 12 volts. Just make sure if you're using a wall wart, if it says 12 volts on it, test it because usually they're like 13.5, 14. That will still work, but if you use like a 14 volt power supply, that's going to be like 16, 18 volts, and that will fry this. Same thing too if you use a 7 volt power supply, it's going to probably be closer to 9, which would be fine. Just make sure to take your multimeter and check it out. All right, now currently I just have 2 pieces of tape holding this closed. I still gotta go to the hardware store and get some screws for this. I didn't have any screws that fit this box. I just had this laying around, didn't have a cover for it, so I repurposed it. Took a little piece of wood, made my own cover for it. All right, there. Get that off. All right, open this up. Let's see, we'll put this to the side. So you can see here's all my connections. The LEDs, the push button switch, LCD screen, the 2 potentiometers, and this is the terminal blocks for what to hook into what you're going to control with this. You can see it's pretty simple in here. I mean, it's a lot of wires, but there's really not a whole lot of components to this. I got my 2 relays, and there's still enough room to add a couple more, like if you wanted to have an additional one for humidity, and just, then you just run a 3rd terminal block up there. Then, of course, we've got the Arduino here, and this is the transistor right here that controls the backlight, so you can turn the backlight on the LCD screen off and on. Otherwise, it's just the Arduino in here, the transistor, 2 relays, your LCD screen, potentiometers, LEDs, push button switch, terminal blocks, and then, of course, the temperature and humidity sensor. Not a whole lot to it. I think it only took me about 45 minutes to an hour, and that's because I had to fabricate the top. Otherwise, if you're just wiring just the circuit up, probably like 15 minutes at most. Just take your time when you're building it. It's pretty simple, and the schematic for the circuit and parts list, all that will be on the website. And once again, there will be a link to that in the description below. All right, well, let's go over to the computer, and I'll show you the Arduino sketch that we're using to control this. Okay, I've got the sketch brought up here, and to get this sketch, just simply go to my website, and you'll find the link for that, of course, in the description below, and you can just copy the sketch and just paste it right into your Arduino IDE. All right, well, let's get down to it. Now, to start with, we're including a couple of libraries. First, we're including the liquid crystal display library and then the wire.h library. Because I'm using an I2C liquid crystal display, you could still use just the regular LCD display without being I2C, but it takes up a lot more pins. So I would highly recommend, just if you've got the standard one already, just order the I2C circuit that solders on the back of it, and then you're done. Otherwise, if you are ordering the parts for this, order the display, the LCD display that has the I2C circuit already soldered on the back. Trust me, it's a lot easier to set up and use. And we're defining pins and stuff for the I2C. Don't mess with any of this. Right here, this is your address for the LCD screen. If you're not familiar with using the LCD screen, I have another video on how to set this up and how to find your address and all that. And I'll have a link to that in the description below, and I'll put somewhere up here while the video's playing. There'll be a link you can click if you want to go to that and then come back. Now, next we're including a library for the DHT11. Now, there's another one called the DHT22, if I remember right. That would work with this too. You just have to change the library. Otherwise, everything else should be the same. This is the pin right here. We're defining a pin. This is where the transistor is hooked to that turns the LCD off and on, the backlight. And we're on pin 5 for this. And this here is the defining the pin that the DHT 11 is on. I have it hooked to pin 6. If you hook it to a different pin, just simply change that number right there to what pin you have it on. This here, we're making 2 bytes to store the temperature and humidity value. Leave that alone, don't change that. Next, this right here is we're defining the pins the relays are on. And I'm using pin 12 and pin 11. Then push button is on pin 8. So if you change any of these, you want to put them on different pins for some reason, just change these values. Oh, and before I forget, I was using an Arduino Nano to control this. You can use an Uno. If you wanted, you could use a Mega if you're hooking a ton of relays to it or something. But the Nano or Pro Mini works great for this because it's small and we don't need a whole lot. So I would recommend the Nano or the Pro Mini or the Micro or one of those. You could probably even use the Lily Pad in this. But the Nano's the one I recommend. That's nice, easy, and they're cheap. They're only like $2-3. All right, next down here, we're defining some integers, and this is for reading the potentiometers and the previous values and stuff, and that's to keep the LCD screen correct, and I'll show you that in a moment. So don't change any of these, and you might need to add some if you're adding the humidity. You might want to add some more values here to keep the value. All right here, this I was showing you I have a difference, temperature difference, so when it triggers it, it actually has to go 5 degrees before it turns it off. And you can see I got 5 right here. This is what you change, and actually I'm going to change it to 1 because that's what I'm using in my egg incubator. But yeah, just change this number if you want it, you know, the temp drops so low, the relay's triggered, and then you want it to go like maybe you want it to go 2 or 3 degrees above that before it turns it off. And this is where you put that right there. Now we got the void set up. We're just initializing the LCD. We're clearing it, setting our pin modes, and then we're writing our data to the LCD screen, the temperature, low, high, and the Celsius. The actual readings that are being written to it are being taken care of in the void loop itself. And yeah, let's move on down. So we're in the void loop, and what we're doing here is we're reading the potentiometer values, and then we're mapping it. And if you want to have a different temperature range, I am using 0 to 40 degrees Celsius. If you want it to maybe go like 10 below 0 and up to 90, you can do that. Just change this here is your low value, the maximum low, and this is the maximum high value. Just change these if you want to have more of a range. I put 0, which is freezing, to 40, which is like 90 some degrees Fahrenheit. And I figured, you know, for the project I'm setting up, this is going to work perfectly fine. And here we're just making sure it's reading, and if it doesn't read the DHT11, it returns and goes back instead of going through the loop. Then here what we're doing is we're reading the temperature, and we're setting that to our integer temp. Now this is what we're using to keep the LCD screen correct. Because if you go from a value on the LCD screen from 10 down to 9, it'll read 90 on the LCD display. So what we're doing is we're checking if it was previously 10 degrees and you dropped it to 9. What it's doing is it's clearing the value that's written in there. It's erasing everything on the screen so that when we get down here to read it, it puts it in correctly. So it'd be 9 degrees instead of 90. And we're doing that for both temperatures. Or excuse me, yeah, both potentiometers we're doing that for to set the value. It's pretty easy to do. All right. Now this right here is where we're actually writing the temperatures to the LCD screen. Don't change any of this. I don't see any reason why you'd want to change any of that, but just leave all that alone. Then right here we've got the if statement, and this is detecting if you push the button. And you got to hold the button for about a second before the LCD will turn off, and you got to hold it about a second before it'll turn back on. I just did that because that's the easiest way for debouncing a button in Arduino instead of having to add capacitors or a debouncing setup in here. It's just easier to do it this way. Now we're down to our if statements for the relay 1 and relay 2, and this is where it's reading the temperature and deciding if it should turn the relay on or turn it off. And that's all there is to it. And then we got a delay down here of half a second. That's just to keep it stable, and I didn't see any point of having to read this thing like every microsecond. You could actually even put this to a 1 second delay. The only thing is when you turn the potentiometer, there'll be a second before the LCD display shows what temperature you're selecting. And I found 500, half a second is perfect for this. So that's all there is to this. It's not a very complicated sketch. And like I said, you can just go to the website and copy and paste it right in your Arduino IDE. If you have any questions about this, go ahead and leave a comment below, and I'll do my best to get back to you and help you out if you have any problems or questions. Also, you can go to the Facebook page, and I'll have a link to that below too, and you can leave your question there. Actually, if you put a question on Facebook, I'd probably get it quicker because I check Facebook more often than I check YouTube. So if you throw it on Facebook, I'll probably get back to you quicker. All right, well, I think we can wrap this tutorial up. I can't think of anything else to go over. So, like I said, the parts list, the schematic, the code, everything's on the website, so check that out. So I'd like to thank you for joining us here today at the Z Hut. I hope you have a great day and have fun building.